Can you mute your speaker there too? All right. Hello, everyone. Welcome to this meeting of the Warren Astronomical Society. I am your president, Bob Tremblay. Happy New Year, everyone. May we live in interesting times. So for our last meeting in December, we were treated with a planetarium show, and I chatted with the presenter, who told me that she's often up in the projection booth there. So if you're there, hi, thank you. That was really cool. And I am reminded of where I learned the constellations. I know a lot of constellations, and I spent a whole lot of time at Flint's Longway Planetarium when I was a kid. So that was quite a treat. So tonight, our short talk will be The Laws of Physics Are Truly Universal by John Dumar. Our feature talk will be 2024 News Retrospective by Ken Bertin and Dale Partin. So do we have any new attendees tonight? We do. Wow, where'd you hear about us?
I found you guys online.
Cool. Online it is. So you get that a lot. Well, okay. Well, hi. We have an observatory at Walcott Mill Metro Park. Every fourth Saturday of the month, we have a free star party and open house, and we open up the observatory. And usually, a member or two or 10 will bring their scopes and set them up out on the field. So it's a good time. So glad you're here. Hope you enjoy the show. You can renew or join your membership here with this fellow who has to leave after the break, so get it done quick. Usually what we do is we start the meeting with a roll call. We go up and down the ranks, say your name and stuff. So I'm Bob Tremblay, president. Dale?
Dale TV, editor.
David Baranski, treasurer.
Jeff from Outreach. Ellie Kaplan. Ken Bertin.
I'm Ferdinand.
Being a long card parent member.
Marcus here.
Bringing.
Is it me? That's probably me. I'm sorry. Sorry. Was that everyone? Right. Hi, everyone. All right. Before we get started here, at the December meeting, a key fob that looks like that was lost here. Has anybody seen anything like that? Look in your stuff. Well, the owner of that is quite frantic about having lost that, and it was here in December. So he's checked with lost and found, and nothing's been done. So oh well. If you'd like to order a WAS t-shirt or WAS wearables, they are available from Mark Kedzier. You can see what's available in our newsletter. WAS stickers are available. I have one right there on my laptop now. That's the first thing I did. These are really cool. Do we have any calendars left, or are they all gone?
4.
We have 4 calendars. We have member astrophoto calendars, and we have 4 left, and they're $20. And they're going quick. GLAC meetings, that is the Great Lakes Association of Astronomy Club, are meetings every second Monday of the month. They're the ones who put on the Astronomy at the Beach event in September. And they have asked that member clubs like us have 2 representatives at there. I've been attending them. They'd like something else. So if anybody's interested in attending these things, they're online via Zoom. They last about an hour. Yeah, you can be there. I can help you remember, yes. But they wouldn't mind more. And we are a large club and one of the biggest in GLAC. So I will talk with Jeff after that. Okay, officer reports. Wait, I can't read that. There we go. Cranbrook needs volunteers for a planetary alignment event on January 25th. Here, we'd like 3 or 4 folks with telescopes outside. And if we don't get volunteers tonight, I'm going to send out a blast to the membership, see if we can get some folks here, because we kind of need to pay them back for using this place. So, the banquet last month rocked. Should have been there if you weren't. Thanks to everyone who worked really hard to put that on and pull it off. I got an email from Brother Guy today. Every full moon we do this meetup with someone from the Vatican Observatory or someone Brother Guy knows. He sent me, her name is, our guest is Nancy L. Chabot. I'd never heard of her. I should have. He sent me her Wikipedia page. She is a fellow of the Meteoritical Society. She has been to Antarctica 7 times. She was an imaging specialist, I think, on the Messenger mission to Mercury. She was on the DART mission, which was that mission that slammed a spacecraft into an asteroid. And she's got an asteroid named after her. So I am very excited to talk with her next week. That would be very cool. Now, Brother Guy said that he was thinking about opening one of these full moon meetups up to the public, and I'm going to poke him at tomorrow's meeting to see if I can get us all an invite into this thing. That will be next Monday at noon. So I'll see if I can do that. Okay, Dale Partin, you on the line? Yes, you are. You have any officer reports? I know what you're going to say.
Yes, I know you do. Well, I need particular
Hold on, Dale.
presentations
There's my
for February and
no
March.
audio here. Why? It was working before. Dale, you muted?
No, I'm not
Is
muted.
that me?
I hear him fine.
Yeah.
Should I continue? Well, they need to hear me in the auditorium too.
Yeah, I know. Just letting her know that online it's fine.
Yeah.
Thought I had this working earlier. Unmute. All right, try again.
Testing.
There we go. Sorry. All right. Yay. Technology works.
Okay, so I have long presentations for the next couple of months, but I still need short presentations for February and March. At our Macomb meeting next week, Bill Slogeris will speak on Nancy Grace Roman and the telescope named after her. And then a month from now at Cranbrook, Dennis Conti will speak on the wacky world of exoplanets and how we discover them. So if you have
Awesome.
ideas for a presentation, please let me know. I'm sorry I'm not there tonight. I'm under the weather, but at least I'm able to connect this way.
Great. Thank you, Dale. Riyadh, anything going on with the observatory?
Yeah, hello everyone. Last open house we had was on the 28th of last month, and it started out pretty cloudy. We had a couple of breaks in the sky here and there. We had about 6 people that showed up. Then everybody left and closed the observatory at 7:30. And then about 9:30 or so, 9 o'clock, Dale Partin got a call from somebody. They said they were out of the observatory and nobody was there. So Dale showed up, helped out, and he brought his own telescope and gave them an observing session. Thank you, Dale. Next open house is on the 25th of this month. So come on out. You never know. We can get clear skies, and clear skies in the winter are absolutely beautiful. Dress for it, though. It's going to be cold, I guarantee you. That's all I have. Thank you.
All right. Thanks, Riyadh. The Metro Park site, the Walcott Mill Metro Park site, has an astronomy link. If you go there, it mentions that they partnered with us, and they have our logo there. Underneath, they have something with the playground they have there with a bunch of pictures, and I'm like, I want pictures. So I wrote the guy, and he said, send me pictures. So we need to get some really cool pictures of folks doing astronomy stuff that we can put on the Walcott Mill site to get people excited about coming out to the observatory. So if you got a couple good pictures of folks out at the observatory or of the observatory, send them to me and I will get those on their website. So David, what's going on with the Treasury?
Okay, so in our cash box, we've got about $470. Our WAS checking account, we've got $23,447. Credit card, there's no balance on there at all. And on PayPal, we've got $908.29. And we have stickers for sale. We got a bunch down there.
Very cool.
And that's it.
All right, thank you. Charlie, are you there? Is he online? He's not. All right. So, Jeff, what's going on with outreach? Besides the fact that we got Cranbrook wanting our help.
That's the only thing. I don't know, where am I who has a telescope? I'm gonna trick people. I need you to come to Cranbrook. As always, yesterday, my wife's like, I want to do this thing, 18th or the 25th. 18 would be better. Yeah, but 25th, because the 18th, this other thing. All right, do it the 25th. So I can't do it. I already am spoken for. If you want to borrow my telescope, just come see me at the break. If you're willing to bring it here, it's good enough. Cranbrook's kind of our home field. Yeah, like it would be nice if we look good in front of Cranbrook.
If we supported them.
Yeah. We also have scopes in the observatory. So if you're like, hey, I can run a simple Dob, I just don't have one. Can I get one? We can get you something by the 25th. So there are means, great ways to help.
Hey, new members, they might want to relieve us of one of those telescopes.
We also have telescopes that we'd like to sell if you're interested, but
Very inexpensively.
I need to get those back into the WASP. That's it. Dale Partin is in the computer. He's doing something at Seven Ponds. So if you like Dale Partin presentations, which are pretty darn good, maybe he can. I'm misremembering which one it is. Is it your latitude longitude?
Yes.
Okay, lat and long. That's good stuff. So Seven Ponds, beautiful nature center they have there, and then they do their observing after their presentations. So it's kind of a hybrid meeting in that way. So that's pretty fun. Also on the 25th though. So if you're planning to help us at Cranbrook, don't go to Seven Ponds. That's all I got.
Jeff, could you tell us what they wanted us to do on the 25th?
They specifically were hoping to get telescopes.
That's all.
Yeah, there's going to be a planetary conjuncture alignment that evening. A lot of planets in the sky, so they did.
Hold. I'm sorry. I have to say something. Okay. We have a word for the line that the planets are on. It's called the ecliptic. They're always on that line. Every day is a planetary alignment. Just every once in a while, most of them are in the same hemisphere, which it means you can see more of them at the same time. So when we say planetary alignment, they are not, what's that?
Like 10 degrees apart right there?
Yeah, they're not the I can't remember his name. Anyway, yeah. They're not gonna pull the ice caps off, which I remember hearing in high school for a planetary alignment. It's gonna be like here, there, to there.
Hugo.
Across.
Come here, Hugo.
It's going to span
Hugo's
about
missing.
100. It's going to span about 180 degrees of the
Yeah,
sky.
but if you have a telescope and you know where to point it, in the span of 15 minutes, you'll be able to see Saturn, Venus, Uranus, Neptune, Jupiter, Mars. Yeah. That's a planet. And the Earth if you look down.
That's really cool. All right. Our publications person could not be here, but our newsletter rep. New guys, he got a newsletter. He won an award for it. It's awesome. You should read it. It's really, really cool. Available on our website. So if you need to contact our board for any reason, you can contact us at board@warrenastro.org. And so let's start off with our special guest, David Levy. David, take it away.
Thank you. I hope you can all hear me.
You just lost your video.
Okay, but you can hear me, so that's.
Oh yeah. Oh yeah.
Yes.
Today is a very special day. Woke up this morning and I tried to get a look at the new comet Atlas. Even though it is first magnitude right now, It's rising too late and I couldn't see it. I got to its position, but it's still not quite bright enough to be seen in the rising dawn. I'm also doing a lot of solar observations, and this is now beginning my 66th year of taking almost daily solar observations, started on October the 2nd, 1959. And for my poetry tonight, I'm going all the way back to 1667 to John Dryden's Annus Mirabilis. And it's in honor of the fact that in the last couple of months, we've had 2 major comets. And he writes, to see this fleet upon the ocean move, angels drew wide the curtains of the skies, and heaven, as if there wanted lights above, for tapers made 2 glaring comets rise. Whether they unctuous exhalations are, fired by the sun, or seeming so alone, or each some more remote and slippery star, which loses floating when to immortals thrown, or one that bright companion of the sun, whose glorious aspect sealed our newborn king, now a round of greater years begun, new influence from the walks of light did bring. Have you not seen when, whistled from the first, some falcon stoops at what her ire designed, and with her eagerness, the quarry mist straight flies a check and clips it down the
outside.
Thank you very much, and back to you.
All right. Thank you, David. Okay, astronomy in the news. Do we have any news? Yeah, I have news. All right. In exoplanet news, we have passed the 5,800 mark. And the NASA Exoplanet Archive is saying they're expecting 6,000 pretty soon. Now, I was watching a Space Bites by Fraser Kane on YouTube, and he was saying that the Gaia mission is going to be releasing their 4th data set soon, and there should be like tens of thousands of exoplanets in that data set. So interesting time for exoplanets. Also on that site, now this was really interesting. The Exoplanet Archive now has data from the CUTE, C-U-T-E, CubeSat mission, which was short for the NASA Colorado Ultraviolet Transit Experiment. That's the University of Colorado in Boulder. The mission is measuring near ultraviolet transmission spectroscopy of a dozen Jupiter and Neptune-sized planets and monitoring stellar activity of the host stars. Now, CUTE is a CubeSat. It's about that big. It has, this is just freaking amazing, a 20 centimeter by 8.5 centimeter rectangular Cassegrain telescope folded up inside of it, and a near ultraviolet imaging spectrograph. I honestly don't know how they packed all that into that tiny little CubeSat, but it's NASA's first NASA-funded UV optical IR astrophysics CubeSat. It was launched as a secondary or rideshare payload along with Landsat 9 and 3 other CubeSats. It was part of the NASA's educational launch of nanosats mission. Now, how many of you in college, if you had the ability to work on a satellite, how many of you would have done that? I would have. Yeah, I wasn't available when I was in college. So that was pretty interesting. In special interest groups, the T Corona Borealis still has not gone nova, and the sidebar on the spaceweather.com website looks exactly the same as it has for the last 2 months. Solar activity, my space weather, I have an app running on this thing, and it popped up. I did not want you to do that. It popped up with a notification that the KP index was 6, and I'm like, it's never done that before. That indicates a G2 class geomagnetic storm. So yeah, so we're solar max. That's happening a lot. NASA's Solar Dynamics Observatory, which I like showing pictures of here, is still offline because of the flood at the Stanford University. And let's see if I can bring this up here. Spaceweather.com. They've been using amateurs. Amateur is that. Okay, I'll just type it in. There it is. They've been using amateur astronomers to take pictures, and this is the sun. That's it. Online people can't see that, but that's the sun today. Zoom, share that. This is probably what David saw this morning. There are a lot of sunspots out there right now. A lot of activity. So if you're on Facebook, check out CME Alerts and the Solar Activity Group. They both have stuff about the sun. So Double Star, Riyadh, what is
So
going
for
on?
the next open house on the 25th, I'd like to, hopefully if it'll be clear, I'd like to look at the trapezium and see how many people can see the G and H stars in the trapezium. Also, we'll look at Zeta Orionis and as well as Rigel. So there are a few really nice, beautiful double stars and some really challenging ones to look at.
Awesome. If anybody wants to start a special interest group, great. Go ahead and do it and let us know about it. And we're talking radio, computers, technology, education, light pollution, whatever. We'd love to get involved in all that stuff. Let's see. Do we have any observing reports or astrophotos by people? What do you got, Ken? Come on up.
How many of you can tell me what happened 415 years ago tomorrow?
Ugh.
Gotta be Galileo.
Galileo discovered the three of the four moons, Callisto, Io, and Europa, on January 7th in 1610. And he didn't see Ganymede because it was behind Jupiter at the time. He didn't see it till the 13th of the month. But this tomorrow is an anniversary of when he got in trouble with the church.
So I've heard, I was actually thinking about this on the way on the drive here. You know, Galileo was referred to as the father of modern astronomy, right? Isn't Edmund Halley also? What about Isaac Newton? What about Copernicus? Let's have a debate. Who's the real father of modern astronomy?
Probably Kepler. Maybe Copernicus.
Yeah, I mean, they all contributed.
Would have been Ptolemy too.
Any observing reports? Anybody see anything in the sky?
Last night, I don't know whether you saw it, was a little clear the other night. And Mars is at opposition. It's very bright, sitting right in near Gemini. It's just a little bit to the left or right, left of Castor and Pollux, and it is remarkable. You take a look a little bit toward the west, you will get to see Jupiter, and that is also pretty close to it back now. Also, the last one was Saturn was occulted by the moon last night, but the moon was occulted by the clouds.
Yeah, I didn't see anything. Anybody else? I saw the moon on the way here. It was pretty.
Yeah, impressive.
Not that I stared at it very long because I was driving. All right, John, you ready to set up?
Yeah.
All right, we are going to start our short talk. So I'm going to disconnect here and John is going to connect up. Mute. Be talking here. Mute. Right. And oh, don't need that. I can just sit there. Switch.
Bob, are you going to introduce John, or do you want me to do it?
We have no audio online.
All right, there we go. Testing, testing.
Yes, got you now.
All right, sorry about that. Share.
Start over.
Share which one? This one?
Yeah, that one.
Thank you.
Thanks for letting us know. And I'm going to take this down to tiny. Where are you? This always misses me up on that one. I want that pinned. And now, there you go. Now it's out of the way. And
From beginnings.
I'm so blind.
Display settings.
Yeah, I'll let you do it.
Yeah, okay.
Thanks.
All right. All right. You gonna be online?
Yes, thank you.
Very good, thank you. So again, I've always wanted to tell my students that the laws of physics are universal, and not just to say it, but actually show reasons that we do know or do know why that they really are truly universal. We're just going to take a look at the law of gravity today, not all the laws of physics, just the laws of gravity. And so the on the shoulders of giants, Galileo, Kepler, Newton, the law of falling bodies, gravity provides or makes things fall at the same rate, 9.8 meters per second squared on Earth, 1.6 meters per second squared on the moon. And so Newton explains why that happens. The mass of the apple, the mass of the hammer, the feather, they get canceled, and you're left with only the mass of the Earth. So I have this video. I'm hoping that it plays. Classic. Dropping a hammer and feather on the moon.
and found our drone and the EPD.
So if you've never seen that, it's kind of neat to see, right? That they actually fall together in a vacuum. Kepler's third law, also explained by Galileo. A little picture on the side there. The green is a planet. The yellow at the focal point of the ellipse is the sun. A is the semi-major axis of the ellipse. And so Newton explains T squared equals Ka cubed, Kepler's third law. So if you put together Newton's law of gravity and then the centripetal force, you get Kepler's third law. So what Kepler finds, Newton explains. What Galileo finds, Newton explains. So we now see the laws of physics at work on the moon. How about the rest of the solar system and onward? So here's a graph of our solar system data. The orbital parameters of the period and the semi-major axes of the planets. I included Pluto. Sorry, if you don't mind, I'm a little bit of rebel. I like Pluto, right? You like Pluto. And so if you do a logarithm plot, the logarithm of the period, the logarithm of the semi-major axis, you get a nice straight line, and the slope should be the exponents of the period and the semi-major axis square and cube. So you get a slope of 3/2 in the log plot. And using the data of the planetary data, you get 1.4996, which is, that's 3/2. So here's an example of our solar system data. So what I wanted to do was, what about other solar systems? Do they obey Kepler's third law, therefore obey Newton's law of gravity? Okay. And so what I did, I went to the Exoplanet Archive, okay, which seems to be a hot topic these days. And what's better to see the solar system, or the universe, other planets? And when I went to the archive to do this, there were still under 5,800 exoplanets. Most of them are found by the transit method. What's that? I'm sure we're gonna have a talk on that, but I have a couple of videos of how these things are found, and I'm hoping that these things work. Good. So as a planet comes around, goes in front of the star, the amount of light that we see diminishes it. And so this is called the transit method of finding exoplanets. And the periods have to be kind of short for that, to see it over and over again. And we get out of this. Go back. And here's direct imaging. This is really cool. No, I don't want to picture this. No, 10%. Okay, there we go. So here's 4 planets being imaged over a 12-year time lapse. And of course, they're following elliptical orbits.
We can't see the videos online.
Can't see the videos online? It's all right. Everybody else can see them. But they follow elliptical orbits, so they have to obey Newton's law. Otherwise, you can't have a conic section. Gorgeous. Right? Just amazing that we can actually see the images of the planets around their star. Yeah, I'm gonna stop this if you don't mind. Beautiful though. So what I did, I was I wanted to gather exoplanets from systems that were four or more, so I can see a straight line of Kepler's law. When you transfer the data over, it comes all in columns, and so the period in days, I change that to years. I get the semi-major axis in the astronomical units, and I take the log of those, so I can easily plot them, in another program. So I gather that data. Here's TRAPPIST-1. It has 7 exoplanets, and the slope should be 3 halves. It's 1.5002. It's 3 halves. What's nice, what's interesting about these are all found by the transit method, and I was kind of afraid of doing this kind of thing because if they use Kepler's law to get the data, then I'm just doing an exercise. But if there's errors in the period and errors in the semi-major axis, then they were measured. So these things are measured. There's columns there that shows the errors. So TRAPPIST-1, some interesting things about TRAPPIST-1. Gravitationally, there's a trio of Laplace resonances, like the Io, Europa, and Ganymede are in a Laplace resonance 4-to-1 ratio, and there's 3 of these ratios in this 7 planets. They were discovered in 2016. The periods range from 1.5 days to 19 days. They're really short. They're around a red cool dwarf star, so very dim, and they lie in the same plane as the Earth, so the transit method works really well for these planets. The resonances are thought to be very stable over billions of years, so kind of neat. So, but we have a nice straight line, log plot. Another example, Kepler 80. It's 1,223 light years away. 6 exoplanets. 5 are shown here because there was no data for the semi-major axis, so it wasn't included. Kepler 80 is a red dwarf star. The first 5 exoplanets were discovered in 2012, the 6th in 2017. They're all within 0.2 astronomical units of their star, so they're within the orbit of Mercury. They're real close. Right? And they're locked in three body. We lost. Somehow we lost. I must have hit something.
Yeah, there's a real sensitive that thing.
Yeah, okay, sorry about that. I didn't mean to hit that. All right, good. So there's 3 body mean motion resonances in those planets. Then the third example I have is HD 191939, 6 exoplanets, a slope of 1.4962. So they're all around 3 halves. It is 174 light years away. There's 3 gaseous giants, smaller than Neptune. Another 2 in 2001, one being a gas giant, the other one is a substellar object, so very close to being a star. And the 6th one is around the near mass of Uranus. So, but what's interesting, you get all straight lines. They follow Kepler's law, therefore follow Newton's law. And from that straight line, you can get the mass of the star. So it's nice to have direct evidence that these laws of physics are universal. They're not just for Earth, not just for the moon, not just for our solar system, but the entire universe, at least our galaxy. So, thank you.
Any questions?
Thank you for that presentation.
Yes,
The last, star you were talking about, was that also a red dwarf star that they?
oh, it's a yellow main sequence star. Yeah, yeah, it's not. What's that?
G class, right?
Yeah,
G, okay.
I think so. I don't know the classes of stars that well.
That would be the OB factor district, I think.
Uh,
G star, you said it's a yellow.
Yellow main sequence star, yeah.
Like us. Okay.
Yeah, like us, yeah.
Any insight on how Kepler gets semi-major axis data? How they
I read a paper on that, and there's some geometric equations that they go through to get that. So it can be calculated by the transit method. I was having a hard time following it when I was reading it, but there's that method to get that without using Kepler's law to get it, because you get the period nice, right?
Right, yeah.
But a little more geometry to get the semi-major axis from it.
It's a spherical trig.
Yeah, there's a lot of lines drawn from the center of the star and the angles and how long it was inside the transit.
Okay.
Yeah, interesting. But any other questions? One more. Lawnmower recurve compound.
Oh, really?
Yeah.
Okay.
Yeah.
Talk at the break.
Okay, very good. Thank you.
All right, speaking of the break, we're going to take our break for the next, what time is it anyway? So 7:41, that's almost perfect. So meet again at a quarter after 8. We're gonna take a half-hour break here, and we're gonna have a feature presentation. That'll give us time to set up Ken.
Thank you.
Yeah, you're good. All right.
No. Where did you shoot at?
I mean my home base.
Yeah.
Royal Oak Archers, my
Okay.
home club, and I shoot at another club during
Nice meeting you.
indoors.
Yeah.
Thanks.
That's the base. I go around and I give presentations every.
Yeah. Okay.
Yeah.
I practice 4 or 5 days.
Just make sure it works.
Okay, so that's what's going on here. So now,
Hit mute on that.
oh yeah, mute. This one?
Now, yeah.
Oh, Alexa, turn off the pasta timer. Oh, it's awesome. Whatever you want. I got it back.
Testing, testing. Can the internet hear me? All right. Are you ready, sir?
Anytime you want, baby.
All right. I don't know why this thing is here. All right, we ready to start? All right, so our feature presentation tonight will be by two people, Ken Bertin, who is here, Dale Partin, who is online. Ken is a hobbyist astronomer who for over 60, let me try this again. He's a hobbyist astronomer for over 65 years, past president and vice president of the WAS, winner of the James Searles Award and a lifetime, John Searles Award, and a lifetime membership. He's observed 13 total solar eclipses, 6 annular eclipses, 6 transits of Mercury, 2 transits of Venus, 15 lunar eclipses. He does our presentations of historical figures in astronomy and is currently presenting online to schools and other organizations. Ken's topic, review of 2024 news about the solar system. And we're doing Dale afterwards.
Dale will do the news about the.
All right, so I'll introduce him, but Dale has a doctorate from Carnegie-Mellon University. He's our first vice president. He worked as an industrial physicist in the automotive industry for 32 years. He bought his first telescope in 1997 and joined the Warren Astronomical Society in 1998. He's been an officer for at least half the time since then. I know that feeling. He teaches astronomy at Macomb Community College. His topic is also review of 2024 beyond the solar system. So with that, Ken, come on up and start.
Terrific. The hardest thing today was working with this. Now, why are we doing this? Is to sign on to see profile? I don't need to do that. I don't know what the hell it's doing here. It's there. That's it. I guess we're good to go.
I don't see that.
I think we're good. Yeah.
Oh, you're the blank one.
Yeah.
So you got to-
And I'll just do this. No, I won't.
There
we go.
All right.
Oh, isn't that fun? All right, it's working. Is what right now it's working. Okay. Again, thank you for your introduction. And Dale will come on, and I'm going to do just the planets and the solar system itself. I'm not going to do the stars and such, but Dale is. What's that? No. Dale is more than capable of giving you all that. He really knows his stuff, and I'm very, very proud to be his friend. As you have questions, this part of presentation probably will take probably about 30 minutes tops, maybe a couple of seconds longer than that. And I'll brief in it if I start seeing you falling asleep. All right. So here we go. This is in the news for 2024. And this is what we want. It worked. All right, here we go. On April the 8th, 2024, we had a total solar eclipse It was known as the Great North American Eclipse. It was a total solar eclipse visible across a band covering parts of North America from Mexico to Canada and crossing the contiguous United States. Solar eclipse occurs when the moon passes between the Earth and the sun, thereby obscuring the sun. Total solar eclipse occurs when the moon's apparent diameter is larger than the sun's, which blocks all direct sunlight and allows some of the sun's corona and solar prominences to be seen. Totality occurs only in a limited path across the Earth's surface, with a partial solar eclipse visible over a larger surrounding area. So for example, you were here in Michigan. If you didn't go see the center line and you didn't go to the middle of the eclipse, you didn't see a total solar eclipse. It was cool because it still covered the sun, but as many people say when they see their first solar eclipse, is when's the next one? It's a spectacular sight. During this eclipse, the moon's apparent diameter was 5.5% larger than average due to occurring about a day after perigee, or perigee if you like, with a magnitude of 1.0566. The eclipse's longest duration of totality was 4 minutes and 28 seconds near the Mexican town of Nazas, Durango. This particular eclipse occurred at the moon's ascending node of orbit. Totality was visible from 6 Mexican states, 15 US states, and 6 Canadian provinces. Approximately 44 million people lived in the path of totality, including 32 million in the United States, 6 million in Canada, and 6 million in Mexico. The largest cities in the path of totality accounted for 1/3 of this population. 5 of the 10 largest cities being in the United States, 3 in Mexico, and 2 in Canada. Adding people who traveled to the path of totality, an estimated 50 million people experienced the total solar eclipse. Meanwhile, about 652 million people experienced the partial eclipse. Eclipse was the first total eclipse visible from Canada since August 1st, 2008, and from the provinces since February 26, 1979. It was the first over Mexico since July 11th, 1991. I'm going to give you a quick thought about that. If you know anything about eclipses, they follow a series, and it's called a seros. And every eclipse that occurs 18 years and 11 days, 1/3 around the Earth. The path looks the same. So the one that was in Mexico in 1991 again appeared in China in 2009. I went to see that as well. It was the first, also the first over the United States since August 21st, 2017. Many of you may have even seen that one, and that was went across the mid part of the United States. Very, very neat thing. This is the only solar eclipse in the 21st century with totality visible from all 3 countries. The next total solar eclipse in the US will be on March the 30th, 2033, which will pass over Alaska. And the next solar eclipse contiguous United States will be on August 23rd, 2044. I will be celebrating my 98th birthday. The total solar eclipse, a similar width, will take place on August the 12th, 2045, which will traverse coast to coast in a trajectory similar to the 2017 eclipse. Let's go to the next interesting thing. We had Northern Lights display. It hit a 500-year peak in 2024. NASA and the National Oceanic and Atmospheric Administration announced in October. Did I lose it? Okay. Doesn't sound like it's.
Yes.
It's doing its own thing again.
Probably touch this thing right
Do you remember this part? Oh, okay. There we go. Buttons. What do we do without computers? I don't. Actually, we enjoyed life. Okay, here we go.
I wouldn't play computer games all the time.
I know. The kid that's behind you right now, my grandson is an expert in 27,000 games. All right. The the National Oceanic and Atmospheric Administration announced in October that the sun's 11-year cycle had reached a total maximum, increasing the rate of space weather events like electromagnetic radiation or solar flares. The bubbles of plasma that burst along with those flares are coronal mass ejections. Now, if you saw it, and you used your cell phone, you saw it, because the cell phone does something about its mixture that makes it apparent to you. And if you see the sky getting a little red sometimes, you might be having a little coronal activity or a aurora, and you can go see it as well. So it's very, very cool. As a matter of fact, the second picture here was taken from my backyard. Okay, so there you go. Solar activity has exceeded expectations during the peak, according to NASA, with expects a solar maximum to continue into 2026 before decreasing through 2030. In May, NASA had a track with strongest geomagnetic storms to reach Earth in 2 decades. That's the strongest, caused by multiple solar flares and at least 7 coronal mass ejections, resulting in possibly the strongest northern lights display in the past 500 years. Solar activity picked up in the following months before the peak, according to NASA, with the most powerful flare of the solar cycle occurring on October the 3rd, an event that forecasters warned would significantly impact radio communications, electric power grids, navigation signals, and pose risks to spacecraft and astronauts. A severe geometric storm was forecast for October 11th, with aurora borealis displays become visible as far south as northern Florida. That's amazing. By the way, in the north, it's an aurora borealis. In the south, it's an aurora australis. Smartphone cameras, like it says, are more sensitive to the colors of the aurora and can capture the northern lights if night mode is enabled, even if the event isn't visible to the naked eye, according to NASA. If using a regular camera, National Geographic recommends using wide-angle lens, high ISO value, and focus set to the farthest possible setting. So understand, we're going to get to see quite a bit more. Coronal mass ejections, we're very lucky that coronal mass ejections did not happen while the astronauts were going to the moon. Had they done it, they could have been killed. So what we need to do is, if we're going to go to Mars and we're going to be out there for 4 years, 10 months there, 2 years there, 10 months back, you better protect them from coronal mass ejections. There's no electromagnetic field, a magnetic field around Mars, none. So everybody's at risk for the whole particular time. Going on. In September of 2024, the Earth had a temporary mini-moon called 2024 PTS, which was captured by Earth's gravity from the Arjuna asteroid group. The size of it was about 10 meters in diameter. That's about 30, I think that's 30, well, I'm trying, never mind. It orbited the Earth in a horseshoe shape for 57 days, from September the 29th to November 25th. 2024 PTS is what it was called, is part of the Arjuna asteroid belt, which is made up of space rocks which follow orbits similar to the Earth's. It will return to the Earth's orbit in 2055. Another mini moon is an asteroid that's temporarily captured by Earth's gravity and orbits the planet. The length of time a mini moon remains in the orbit depends on its speed and trajectory. Other mini moons have had Earth orbited the Earth, including in 2020, one called CD3, bound to the Earth for several years before leaving in 2020. In 2022, NX1 orbited the Earth from 1981 to 2022 and will return again in 2051. Earth is getting a tiny new moon. It won't be the first or the last. And in September of 2023-24, orbiting or just flying by a mini-moon is a temporary captured orbiter if it completes at least one full orbit of the Earth. The Earth has caught a second moon, scientists say, September the 2024 through 2029. NASA scientists calculate the Earth should have captured a second moon on Sunday, September the 29th. The mini-moon orbited for 2 months and left us in November. Let's move on. Okay, we had a rare supermoon eclipse on the night of 18 September. How many of you actually saw that? Did you get a chance to see it? Kind of like interested to see. All it did is it hit a little bit of the umbra, that's the solid part of the Earth shadow, and it just went right across the top. I went outside I sat on a chair and watched this little thing happen. You can see it up there on the top. You can see that again, this was named as Saros also. So you can get the idea that the sun, there's Saros, is also lunar Saros. And you can see that the umbral shadow, that's the main part of the Earth, hit the moon at the top right there. You can see that. And it was visible all over that area. And very, very cool how it looked. Not as much fun as a total lunar eclipse, but very nice anyway. It coincided with the second supermoon of the year. The eclipse was visible from parts of the Americas, Africa, Europe, Western Asia, Antarctica, and southwestern Russia. This partial lunar eclipse occurred at the moon's ascending node of the orbit on Wednesday, September the 18th, 2024, with an umbral magnitude of 0.0869. Now, the atmosphere of the Earth produces what is known as a penumbral eclipse. Okay, so the moon was actually covered by the entire shadow of the Earth, but not the Earth, the physical hard part of the Earth, the land and such, and the globe itself. But the atmosphere also contributes to this type of eclipse. A partial lunar eclipse. A lunar eclipse occurs when the moon moves into the Earth's shadow, causing the moon to be darkened. A partial lunar eclipse occurs when one part of the moon is in the Earth's umbra, while the other part is in the Earth's penumbra, like I said. Unlike a solar eclipse, which can only be viewed from a relatively small area of the world, a lunar eclipse may be viewed from anywhere on the night side of the Earth, occurring only about 7 hours before perigee on September the 18th at 9:20 Universal Time. The moon's apparent diameter was larger than it's been, and this was what is known again as supermoon. Simply what we're talking about with a supermoon, it's closer to the Earth. That's why it's called a supermoon. This eclipse also occurred during, again, as it says, a supermoon, which was when it was very close, and you can only have an eclipse when the moon is full. Okay, when it comes to that, the eclipse was the final partial lunar eclipse of lunar Saros 118. Now, what are they talking about? The final partial lunar eclipse. That means that the next time that they're lined up like that, the shadow won't hit the moon. So there you go. And that's what happens as Saros has an area, a time factor of the number of Saros could be 80 years, whatever it is. I don't remember the exact number, but you can have a lot of eclipses in a Saros. Okay. The eclipse was completely visible in North and South America, West Africa, Western Europe, seen rising over Western North America and the Eastern Pacific Ocean, and setting over East Africa, Eastern Europe, and the West and Central. Okay, we have discovered another very interesting thing that occurred. We've been doing a lot of studies with the moons of Jupiter and several other moons around the area. And what we found out this year was that Io, or Io if you'd like, it's actually pronounced Io, but everybody says Io, but it's Io. Its magna ocean may not exist after all. We thought that it has a magna stuff, if you want, as its ocean. Plenty of worlds in our solar system have oceans, and not all of them are made of water. Io, Jupiter's innermost moon, was purported to have one made of basalt and bits of sulfur just under its surface, powering its volcano eruptions. Remember, Io, we see volcanoes on Io. Right? You don't see them very many places, and I don't think there's any other moon in the solar system, I think, that it has any volcanic action that we can do it. We do believe that Venus has volcanic action also, still to this day. Io is close enough to Jupiter that it is constantly pushed and pulled by tidal forces. These tidal forces pull magma to the surface, and it was believed that these forces also kept a large shallow reservoir of magma bubbling under its surface. However, instead of an ocean, the study's lead author, Ryan Park, a senior research scientist at NASA's Jet Propulsion Laboratory, suggests Io may more likely has a porous mantle with chambers that allows magma through. The rocks are partly molten, similar to the under Hawaii and the Iceland and on the Earth. It's kind of like a slushy, solid material, like an ice, with melt water in the cracks in between. The melt eventually escapes to the surface and erupts. The study relied on Doppler's data from 2 Juno flybys last year, as well as less sensitive data from its predecessors, the Galileo spaceship. Essentially, as the spaceship encountered Io, measurements are made by gravitational instruments aboard the spacecraft. The encounter affected the acceleration of the spacecraft on first approach during the flyby, and as it left the system. This could be triangulated by measurements between Juno, Io, and NASA's Deep Space Network, a system of telescopes that downlink data from off-world spacecraft. Another great thing that happened this last year was comet, I cannot pronounce this word, but it's Tishun-san Atlas. Anybody have a better work at that? It is known as Atlas IC 2023 A3. It was visible at first in 2023, but it was visible most of 2024. It was visible to the naked eye after sunset on October the 12th, 2024. As it moves away from the sun, it passed by the Earth on October the 12th, although its closest approach was 44 million miles away. 44 million miles away is a little farther than Mars, actually, from us. Comets are classified as either short period, with orbits that take less than 200 years to complete, or long period, which take longer than 200 years to complete. Long period comets, like this one, Tishun Atlas, are thought to originate in the Oort cloud, a region in the farthest edge of the solar system, more than 40 times farther away than Pluto, by the way, where the gravitational pull of the sun is so weak it completes with tidal pull of the galaxy and passing stars. Objects in the Oort cloud are composed of frozen gas, dust, and rock, and occasional gravitational interactions can send these objects toward the sun, where when they get close enough, we call them comets. Now, this particular comet, I think, is supposed to return to us in around 12,000 years. So that's a long period comet, obviously. To give you in comparison, Halley's Comet, if you want to call it Halley's Comet, I don't care, but it's actually Halley. Halley's Comet comes every 76 years. So we got to see it in 1986. We'll get to see it again, I think, in 2061 or something like that. Okay. This is kind of cool. Can I go away from here for the? All right, let's do it this way. Very simply, if you take a look at the picture up here, you see the comet. That's a very nice picture of it, but these two pictures here are kind of cool. We have a thing called SOHO. It's a satellite that shows us the sun. You saw one of those SOHO shots, like a SOHO shots, with all the sunspots on it. Those are cold storms on the sun, just for your information. If you took the sunspot and put it into space, you still couldn't look at it. All right, that just to give you an idea of how hot it is. Anyway, or how bright. What we do is, this is also one of the SOHO pictures of the comet coming by the sun. The sun is actually that little yellow circle inside the black circle. All right, so you can get to see the corona and stuff, and that was what earlier. And then later on, you see it again getting closer, and that's kind of cool. So we actually saw it going by the sun. And of course, this is the arc of it, and there you go. Very, very nifty thing to see. Wasn't easy to pick up, but the very, very good telescope working astronomers did very well with it, and obviously the professionals did a real great job. Okay, let's move on. The James Webb Telescope, and updated processing techniques. Researchers have detected asteroids just tens of meters across. Over the past 200 years, astronomers have cataloged over 1 million asteroids in the solar system's main belt, down to the size of around 1 kilometer in diameter, but smaller asteroids were elusive until recently, when a team of scientists utilized data from the James Webb Telescope to spot some tiny asteroids as small as 33 feet across, no bigger than a school bus. Decameter asteroids, referring to asteroids tens of meters in size, originate in the main asteroid belt between Mars and Jupiter. Because smaller asteroids are more susceptible to sunlight and thermal effects altering their trajectories, they are more likely to escape the belt and crash into the Earth. On the order of every few years, when they do, they can cause significant damage. For example, in Russia in 2013, a roughly 60-foot wide, 18 meters asteroid exploded in midair, causing a shockwave that injured thousands of people and damaged even more buildings. Being able to detect these objects at their origin in the main belt could greatly increase our ability to monitor potential threats. Anyway, that tells you a little bit about this particular one that came by as well. We get to see them quite often. For most astronomers, asteroids are sort of seen as the vermin of space, in a sense that they just cross your field of view and affect your data, said DeWilt in the MIT News release. Let's see if there's anything in here. The team tested the approach using infrared data from several ground-based telescopes, including Search for Habitable Planets project and the Antarctic Search for Transiting Exoplanets. The team tested the technique on telescopes operating infrared instead of visible light because the main belt asteroids are dark, but they absorb radiation from the sun, making them much easier to detect in infrared wavelengths. The technique worked as proof of concept, and the team published the results in 2 papers in 2024. And there's a little bit more on that too. Well, we had, for the new nature study, the team used 93.5 hours of observations of TRAPPIST-1 from the James Webb as well, and that may be covered a little later on. Space telescopes spotted both carbon dioxide and hydrogen peroxide on the surface of this distant moon. This is Charon, which is Pluto's partner. It's about 700 miles in diameter. It's relatively close to Pluto, certainly compared to what we are with ours, but it is the closest of size from an orbit from a planet and a moon if you want to use Pluto as a planet. I could give you a whole presentation on why they shouldn't, but that's not here. Okay, Charon is the largest and most well-studied of Pluto's 5 moons, was first visited in 2015 as part of the groundbreaking New Horizons mission, which characterized it as a stunningly beautiful world with unexpectedly complex surface features. However, this new discovery makes it plain that there is chemistry ongoing on the surface of the distant moon, making it a surprisingly active place in the far reaches of the solar system. As presented in a study published in Nature in October 2024, scientists from the Southwest Research Institute and a number of cohort organizations have detected both carbon dioxide and hydrogen peroxide on the surface of this moon. The team drew upon new information gathered by the James Webb during a recent period of observation that has followed on the heels of a sort of virtual grand tour of our solar system in its many moons by the well-known Space Telescope. Charon was discovered in 1978, almost 50 years after Clyde Tombaugh had discovered Pluto. In the years since its detection, more and more has been found out about this primordial world, including the exciting detail that Charon is actually so large compared to Pluto that both of them orbit a shared center of gravity that is outside of Pluto itself. This has led some to characterize the Pluto-Charon system as a sort of binary planet, which defies the traditions characterized of worlds and their moons. The Pluto-Charon system is located an average of 3.5 billion miles from the sun, and at the distance of Charon's surface gets down to a frigid negative 364 degrees Fahrenheit. Although the thin atmosphere was detected on Pluto by the New Horizons probe in 2015, scientists believed at the time Charon was simply too small to maintain an atmosphere, but none of the tools brought to bear on Charon were capable of returning spectral data with wavelengths longer than 2.5 unimeters. What is that? The UM, tell me. That's a metrometer. Thank you again. It hit me again. Memory is not great. All right. Leaving plenty of uncovered ground for future work. James Webb has that power, specialized in infrared observing and bringing special spectral instruments to the table. Sylvia Protopapa of SWR1 and her team compiled and examined data from one of James Webb's recent observations of the Pluto-Charon system using this new longer wavelength spectral data. The data shows both carbon dioxide and, like we said, hydrogen peroxide on the surface, as well as ammonia and crystalline water ice. Hydrogen peroxide is often formed when light and radiation interact with water ice, indicating active surface chemistry on the moon's surface. The carbon dioxide, the teams contend, probably originated underground and was exposed to the surface during impact events. Both discoveries shed more light on the frigid happenings of a small distant world like Charon and hints at the compounds that might comprise other objects in the vast and poorly understood Kuiper Belt. So there you go. That's more on that. Let's move on to the next. Okay. We had a bunch of different satellites that went up, and the Chinese had one called Chang'e, I guess it's called, and it's a Chang'e 5 mission. The new results from that mission suggest that the moon possessed a magnetic field well into its midlife, much longer than previously documented. In work published January 1st, researchers report rocks recovered from the sample return mission that are weakly magnetized and just 2 billion years old. While not conclusive, the results add to the growing body of evidence documented the early moon's dynamism. Combined with previous sample return data and observations by spacecraft in lunar orbit, the new results make a strong case that not only does the young moon have a magnetic field, but that the molten lunar interior that must have generated it persisted for much of the moon's lifetime. The research was led by Shuyu Kai from the Chinese Academy of Sciences in Beijing. Also continues the prolific scientific output from the 2020 Chang'e mission. The mission's bounty of 3.82 pounds of moon rocks and soil comprised the first lunar samples returned to the Earth in 44 years. This has provided a treasure trove of insights and the moon's history and physical nature. For instance, in results published last year, researchers were amazed to find the evidence of lunar volcanism a mere 125 million years ago, upending assumptions that the moon has been volcanically inactive for billions of years. The moon, one of the moon's ongoing mysteries is whether it once possessed a magnetic field, and if so, how long it was present. The analysis of samples from both the Apollo missions and the USSR's uncrewed lunar missions have revealed that over 4 billion years ago, the moon had a weak global magnetic field, about 1/20th of the strength of the Earth's present magnetic field. But robotic and crude explorations have determined that the field is now non-existent. Planetary magnetic fields are created by what is known as a dynamo effect, where the magnetic field is created through electronically conductive fluid, usually molten iron, by the rotation of the planet. The planetary dynamo also requires a source of internal heat to drive convection motions through the molten fluid. These conditions still exist on Earth and sustain our planet's magnetic field. These conditions could also have existed on the moon early in its life. The moon formed close to the Earth from the debris created by the collision of a Mars-sized body with the protosphere, proto-Earth, prior to being tidally locked into synchronous rotation, which keeps the same face of the moon pointed to the Earth. The moon rotated much faster than today. Its closer proximity to Earth also created tidal forces that maintain internal heat, promoting the dynamo effect and creating a lunar magnetic field. Currently, there are regions of the moon with localized magnetic fields reaching hundreds of TCS, such as the Rainer Gamma region on Oceanus Procellarum, it's the ocean of storms. These small local fields could be the remains of a strong earlier global field magnetic, but scientists are unsure when that global field disappeared. Samples returned from Chang's offered an opportunity for a fresh data point, adding to what these provided by samples from previous missions. Such analysis also prevented a unique set of challenges. Simply sealing and packaging a sample is sufficient to protect their chemistry, but the collection, transport, and storage of samples can induce magnetism, which must be accounted for in an analysis. So you get an idea that that was a pretty busy trip. We have a whole bunch of other spacecraft and things that went on in the year of 2024. For the fourth year in a row, new world records in space life were set for both orbital launched attempts and successful orbital launches. The year featured the successful maiden launches of Falcon Centaur, Gravity 1, Long March 12, Adrian 6, partially successful, and also more development launches of SpaceX Starships, include its first ever landing on Flight 5. Additionally, the final launch of a Delta family rocket occurred in April with a 4 heavy variant. That's a Roman numeral.
Did IM-1 fall over?
Yes, it did. We've had several unsuccessful things that happened also. There were a couple of them that fell also. And going there again needs work. We need to be better than we got pretty lucky, actually, what it was early on. The New Year's of Universal Time, marking the first launch in the new year, ISRO launched their SPO-SAT for studying X-ray polarization. It will serve as a complement to the present XPE probe of NASA's. Later, ISRO's IDEA 11-1 spacecraft, launched 5 months previously, was inserted into a halo orbit around the Earth, Sun, on January the 6th. It will study the solar atmosphere, solar magnetic storms, and their impact on the environment around the Earth. We have the Einstein probe, a space telescope mission of the Chinese Academy of Sciences in partnership with the European Space Agency and the Max Planck Institute of Extraterrestrial Physics, dedicated to time domain high energy astrophysics, and was launched on the 9th of January 2024. In April, NASA began, under the direction of the Office of Science and Technology Policy, to create a standard for time on the moon. It is called Coordinated Lunar Time. It is expected to be completed by 2026. The Space Variable Objects Monitor is a small X-ray telescope satellite for studying the explosions of massive stars by analyzing the resulting gamma ray bursts, developed by the China National Space Administration. European Space Agency launched Proba-3 dual satellites for solar coronography, on December 5th of 2024. Exploration of the solar system. The NASA's Mars helicopter Ingenuity flew its 72nd and last flight on January 18th. Because all 4 of the rotor bays were damaged, NASA subsequently announced the end of the mission in early this month. On October the 7th, ESA Hera spacecraft was launched successfully. It will arrive in asteroid Didymos in 2026 after a Mars flyby, where it will study the effects of the double asteroid redirection test. NASA's Europa Clipper mission was launched on the 14th of October and will study the Jovian moon Europa while in orbit around Jupiter. The interesting thing about Europa, it may have an ocean. We see steam rising from it, and we're going to go study to see how many fish they have. I'm kidding. Then there was Peregrine lunar lander was successfully launched on the 8th of January in 2024, but after the launch, the propellant leak was detected and precluded any attempt to perform lunar landing. In the end, the spacecraft never left the highly elliptical Earth at any time. It was ejected into the carrier rocket, and the mission ended 10 days later on 18 January when the spacecraft re-entered the Earth's atmosphere. SLIM, S-L-I-M, achieved the first ever lunar soft landing for a Japanese aircraft on the 19th of January 2024, making Japan the 5th country to soft land on the moon. Although it landed successfully, it landed on its side, right? And it was still able to do some things, but not as much as they had planned for it to do. On the 29th of January, the lander resumed operations and was shut down within about a week. And there are several others that have been, actually, I'm going to tie mine up now a little bit. I could go right on through this. We've launched a lot of objects. Let me see if this other one comes through. No, it doesn't. That's interesting. Should have been there. Okay. Anyway, that's the report about the planetary stuff. There are other things that are going along. There were about 300 launches this last year, somewhere maybe closer to 400. 300 of them were from America, but other ones also went from other countries around the world. Space flight has now become a great thing to do, as they say, around the world. And you should see quite a lot of stuff coming forward as the time goes along. Do you have any questions at all for me before we bring you Dale? Any questions? I guess I covered it, huh? Thank you very much for your time.
All right.
What do you want me to do here?
Let's see. Let's close this down. Stop sharing. You don't need that. Actually, it's.
We're good? You want to do that? You can do it.
I can just do it on here, yeah.
Whatever you want. It's good. It's there for you. Okay.
Let's see.
You ready for me to share my screen?
Yeah, I gotta figure out how to get Zoom up on this other screen here. Hold on a second. Wish I knew. You know what? I'm gonna swap out mine. Give me a second, Dale.
Yeah, do it that way. That's probably a very good choice.
Yours.
Then it'll be a little easier to do.
Oh, he can't hear me. All right. So Dale, can you talk? See if I hear you.
Hello, hello.
All right, you're coming overhead. All right, so you're ready to share.
Okay.
You, let's see, hold on. Let me do that. That's pin you and put. Just a
Can you see
little
my cursor?
standard. Where is just you? I want to see all that. Well, I guess I'll see that. Okay, there you go.
Can you see my cursor?
Yes,
Okay.
I'm seeing the presenter view too.
Are we good to go?
Yeah.
Okay. I'm going to pick up where Ken left off, moving beyond the solar system. This is kind of an outline of what I'm going to talk about. Dark matter, dark energy, the crisis in cosmology, galaxies in the early universe, exoplanets, and alien life. This is a fairly standard pie chart showing that dark energy is roughly 3/4 of what there is. Dark matter, a little less than 1/4, and about 4 or 5% normal matter, supposedly. At this point, people have been looking for dark matter particles for years with increasingly sensitive physics type equipment, and they cannot find any kind of dark matter particle. The assumption has been that they mostly interact because of their mass and their gravity, but that probably they interact at least very, very weakly with other forces like electromagnetic forces. But nothing's been found that would confirm that. So a second unpopular option, because it's less interesting, is that dark matter is made, excuse me, made of particles that have mass and gravity, but simply do not interact in any other way. And finally, there is no dark matter. Instead, some version of modified gravity is at play. What that means is you look at how spiral galaxies rotate, for example. It doesn't make sense how they rotate if all that there is to them is normal matter. So there must be some additional matter that makes them maintain their spiral structure. That's been the theory. But an alternative is that gravity acts a little differently once you're out at this kind of range, as opposed to the distance between the sun and Pluto, for example. So that's the status of dark matter. Can't find any particles associated with it. Now, dark energy and the crisis in cosmology, so-called. Dark energy is hypothesized to be causing the expansion rate of the universe to accelerate. You can think of this energy as related to a force that's pushing things apart. The crisis in cosmology results from two ways of measuring this acceleration and the expansion of the universe, which gives two different results. One method uses the cosmic microwave background to derive how fast distant things are accelerating away from each other. The other uses measurements of distant novae, I guess I should say. And some new telescopes should help resolve this, like the extremely large telescope with a diameter of almost 40 meters that's going to go into Chile and become operational in 2028. So this kind of schematically shows Hubble type data, where this is the distance to a galaxy in megaparsecs, which is a big unit. And this is the speed at which distant galaxies are moving away from us in kilometers per second. So if you measure the slope of this data, it had been thought that if you go out far enough, the data would bend over this way, because ultimately gravity would pull things back together or slow down how fast they're moving away from each other. Instead, something like 28 years ago, the curve was seen at large distances to bend upward. So things are moving away from us faster than had been expected. They're accelerating. There's some kind of dark energy involved in that. So if you look at the data for measuring that uptick in speed out here, one way of measuring it is you get this data here. That's based on the cosmic microwave background. The other is based on measuring distant supernovae. You get this kind of data. These are error bars in the data, and the error bars aren't even close to each other. The data is about 10% different from these two methods. So this is the so-called crisis in cosmology. People are trying to do much more accurate measurements to resolve this of distant supernovae and come up with completely new ways to measure this. One way would be measured based on collisions of neutron stars and observing light from the collision and gravitational waves from the collision. All kind of stuff going on there. However, there's another model that says there is no such thing as dark energy. Just like one model says there's no such thing as dark matter that I just talked about. The apparent increase in how fast things are moving away from us in this model is caused by the fact that time is not passing at the same rate in the very distant universe. There are reasons for thinking that that might be the case based on distribution of matter in the universe. So the claim is that both dark energy and the crisis in cosmology go away in this model. What can I say? Stay tuned.
Mm-hmm.
Another topic is the study of massive galaxies in the very early universe. These studies have been greatly enhanced by the James Webb Telescope. So young galaxies were discovered out near the edge of what we can see, which appeared to be far too massive for their ages. Like how can a galaxy get so massive in such a short time? This was not expected. I talked about this a year ago when I gave a review like this on this topic. This led some people to question whether the Big Bang theory was correct. Maybe some totally different theory was correct. However, these early results from the James Webb Telescope were not very accurate. They were based on taking pictures of these distant galaxies with different colored filters in front of the camera. And that's it. Since then, spectroscopic data has been taken much more using the James Webb Telescope, which gives much better results, which says that the high luminosity of these early galaxies is caused by stars that are larger than expected, and also by large, extremely luminous black holes. Obviously, black holes themselves are not luminous. They don't give off any light. But near the black hole, matter, as it's getting sucked in, it's accelerated at very high speed and bumps into other matter and gives off lots of radiation before the matter crosses the event horizon into the black hole. For example, a galaxy was found with the Webb telescope that's less than 800 million years old. It has a supermassive black hole with 400 million solar masses in it. That's 40% of the total mass of the galaxy. That's sort of a lot. Our central black hole for the Milky Way has about 0.1% of the mass of the Milky Way galaxy, not 40%. People are realizing that the early universe was real different from what the universe is like now. It was much hotter and it was much denser. Things hadn't spread out that much yet. So you can get these very massive stars and massive black holes forming because there's a lot more matter in a given volume. So the Big Bang Theory is safe. Still works. Another discovery in 2024 was observations of what's called the plunging region around a black hole. If you look at a model of a black hole, here's a black hole. Here's the event horizon where anything that passes through the event horizon is trapped in the black hole, cannot escape. But there's another radius 3 times bigger than this radius called the ISCO radius. It stands for Innermost Stable Circular Orbit radius. 3 times the event horizon radius, as I think I mentioned. So out here beyond this radius, matter can be in a circular orbit and be in a stable orbit. But once it gets into this region here, which is called the plunging region, there's no stable orbit. So it's sooner or later, it's going to wind up crossing the event horizon and into the black hole. So in this region, there's fierce collisions between different objects, very high energy collisions, gives off a ton of X-rays. And these X-rays have now been observed from a black hole in our galaxy. It has about 8 times the mass of the sun. This is the first observation of matter as it's falling into the black hole. And of course, the James Webb has again found a most distant ever observed galaxy with a redshift factor of 14.3. Light's been traveling our way for 13.4 billion years. So the galaxy was only 300 million years old when it gave off the light that we now see. So stay tuned. I'm sure even more distant galaxies will be discovered. Another record breaker, the fastest growing supermassive black hole ever found has 17 billion solar masses in it, and it's accreting or swallowing, you might say, 1 solar mass per day, not per year. It's sucking in the sun's worth of mass every day. 0.1 to 1 solar mass per year is the usual rate at which black holes are pulling in matter. The accretion disk from which this matter is falling has a diameter of 7 light years. For comparison, for M87, which was imaged, I don't know, a couple years ago or so, that has a diameter of 0.013 light years. So this one is like 500 times bigger than this one. So this illustrates, though, even though this black hole was not out at the edge of the universe, but it illustrates that black holes, if they're in a region where there's a lot of mass, very densely compacted, it can pull in a huge amount of matter every day and grow rapidly. Okay, final topic, exoplanets and alien life. Over 5,000 exoplanets have been discovered and confirmed. Something like 7,000 more have been detected, and they need to be confirmed. When the next Gaia data is released, we may have a whole bunch more. Based on this sample, it strongly looks like there must be roughly 100 billion exoplanets in our galaxy or more. A small fraction of these, let's guess 0.01%, it almost doesn't matter. 0.01% of 100 billion is a big number of potentially Earth-like exoplanets. That is, exoplanets similar in size to the Earth and with a similar temperature where liquid water could exist, and therefore could have alien life on them if alien life is in some sense like life here. So it's going to be exciting as these exoplanets are studied. We've spent several decades looking for radio transmissions from exoplanets. The total number of intelligent radio transmissions detected is 0. I've given talks on this before, and there seems to have been what I can only describe as a blunder, in that people thought they could detect radio transmissions from throughout the Milky Way galaxy. It's now known that that's not the case. There's too much radio noise from natural sources out there. So the distance over which radio transmissions can be detected is less than 1,000 light years. It might be around 300 light years. So we can only see a little bubble around the solar system in which we could potentially detect signals. The new emphasis is on trying to find laser signals. Laser beams are much more collimated than radio beams. So the laser beam stays concentrated for a much larger distance. So you can potentially detect it over a much larger distance. The problem is, it stays concentrated for a longer distance. Therefore, it only points in basically one direction. The signal, unless somebody's aiming a laser beam right at you, you're not going to see it. Unlike a radio beam, which spreads out with distance. In any event, the studies looking for laser signals that have been done have found a big 0 signals. So both of these techniques would look specifically for intelligent alien life. A relatively new way of looking for life, alien life on exoplanets, is to study their atmospheres. Measure the composition of their atmospheres. For example, if you find a planet with roughly 20% oxygen, like our planet has, we might reasonably say that's a strong indication of life, because it would be difficult to come up with a way to produce that high of a concentration of oxygen any other way. So this is a relatively new way of looking for life. The Earth would have had primitive life producing oxygen for billions of years before Homo sapiens came along, relatively recently. And if that's true of some other planet, discovering an atmosphere with some chemical compound in it indicative of life would only tell you that there's primitive life on that planet. But even that would be a major, major, major discovery. So unfortunately, oxygen absorbs light mostly in the ultraviolet wavelength range. The James Webb can mostly only see infrared plus red light, cannot even see blue light, let alone ultraviolet. There are ways of detecting oxygen with this instrument, but they're not very sensitive. And this very, very schematically and crudely tries to give an idea of how you do these studies of exoplanet atmospheres. You have a star giving off light. If the Earth is over here and we're doing measurements on the light we get from that star, if it passes through the atmosphere of an exoplanet, we can see features in the spectrum of light that let us identify what gases are in the atmosphere. Again, it's more complicated than this, but give you a rough idea of it. For example, the TRAPPIST-1 system, John Dumar mentioned this system in the short presentation given earlier, has 7 known planets orbiting this TRAPPIST-1 star, highly circular orbits. They're all in orbital resonance with each other, like 8/5 resonances and things like that. They're believed to be all tightly locked, and they orbit a dim red dwarf star. And this green area shows the estimated habitable zone where you could have liquid water. So there's maybe as much as 3 or possibly 4 planets in the habitable zone. This star is much cooler than the sun, less than half the temperature that the surface of the sun has, and only 9% the mass of the sun. This shows the inner solar system, but the habitable zone, mostly where the Earth is. All of this stuff here is orbiting the TRAPPIST-1 way deep inside the orbit of Mercury. Okay? Deep inside the orbit of Mercury, because the gravity of this star is very weak and its radiation is very weak. In fact, this shows a comparison of how the sun would look versus how the TRAPPIST-1 star would look. You can barely see it. It's so dim and cool. So these TRAPPIST-1 planets are all comparable in size of the Earth, and most of them have comparable densities. The James Webb Telescope is systematically studying them. So far, as I've heard, they've only studied the innermost 2 planets, TRAPPIST-1b and TRAPPIST-1c. TRAPPIST-1a is the star itself. The star frequently has large flares, which is common to red dwarf stars. And you know, there's seemed to be no detectable atmosphere on these innermost two planets, possibly because whatever atmosphere they had was eroded away by these frequent flares. I think I read somewhere that the star flares once a day, once an Earth day. So these planets are extremely close. This is astronomical units. So the Earth is 1 astronomical unit from the sun. These are nearly 100 times closer to their star. So they're right on top of the star if it flares. Studies of the other planets in the system are in process. Here's an example of another star system with a so-called steam world exoplanet. We're talking about another dim red dwarf star. The planet's twice the size of the Earth, orbiting very close to its star, with an estimated surface temperature that's kind of balmy, 660 degrees Fahrenheit. Its atmosphere is largely composed of steam. It's just too hot there to have liquid water. But at least there is H2O there that's been detected. So the coming years will be filled with studies of exoplanets and their atmospheres. These studies will be enhanced when the extremely large telescope with a 39-meter aperture begins operation in 2028, and the Giant Magellan Telescope in 29. Within a decade or so from today, the atmospheres of hundreds of Earth-like exoplanets and the habitable zones of their stars will have been studied. By then, within a decade or so, I would guess, we will know much more about how prevalent life is in the universe. This is just a picture of the extremely large telescope with a 39-meter aperture. They've been building it since 2017, completion 2028. The objective lens has almost 800 mirror segments. The angular resolution of this telescope will be 0.005 arc seconds. This is my final slide, and it'll be a controversial slide. Are aliens here? Some, for example, US military officers, have reported that unidentified aerial objects have been observed with capabilities that go far beyond anything that our military vehicles can match, and is believed to go far beyond what China or any other country here on Earth can match. This includes, I heard a rear admiral talking about this stuff. He said they see objects maneuvering with acceleration greater than 1,000 Gs. He said even greater than 3,000 Gs. He said our most sturdy fighter aircraft fall apart at about 17 or 18 Gs. I can't handle any larger accelerations than that. Needless to say, pilots don't do too well in those kind of accelerations. If it's true that these unidentified objects are maneuvering with these enormous accelerations, we don't know how to do that. How do we explain this? If it's true, I don't know. So that's the end of my presentation. Thanks for listening. I'm open to questions.
All right, no questions for Dale? Or you're off the hook, Dale.
What'd you say?
I said you're off the hook, Dale.
Okay.
All right. So if there's no questions, then we're going to close the meeting up. Our next meeting will be next week, January 16th at Macomb Community College South Campus, 12 and Hayes. Our next star party will be fourth Saturday, January 25th at our Stargate Observatory. And several of us head over to the Red Coat Tavern, which is on Woodward, north of 13 Mile. And with that, good night, clear skies, and Happy New Year, everyone.
Bob,
Yes.
don't forget, emphasize, we need people to be at Cranbrook on January 25th.
Yes. I'll probably be sending out an email blast to the membership about that.